Okay, so last time we started this section on divisibility, and just a reminder about a little bit of vocab because we're going to continue to use this vocab. This definition of divides tells us that if a number divides another one, it means it goes into it evenly. There's no remainders left over, okay? You get a whole number value too. There's not any decimals either. So if a value divides another value, it is called a divisor or a factor. And then that other number that it is a divisor or factor of is called a multiple of the first number. And we're going to continue to use that vocabulary throughout Chapter 4. But in particular today, we're going to use this in what we're doing today. We had several divisibility theorems. I'm not going to go through all those again, but we had this list. Do you remember this crazy list of what happens when you add and subtract numbers and those sorts of things? And then we had some really cool divisibility rules for specific values. 2, 5, 10, 4 and 8, 3 and 9, and then 11 and 6. And we talked in general last time about how the 6 rule is not really specific to 6. It can be used for other things as well, as long as the two numbers that you're dividing out the value into don't have anything in common themselves. And we had done one example, and we're on example 2. All right, so example number 2 is really thinking about these divisibility rules and what actually is true and or false that conclusions that we can make. So this question wants us to classify it as true or false, and we'll give ourselves just a little bit of justification as we go. The questions in your book don't always ask for justification, so if they don't and you just say true, that's okay. But usually when I say something on a test, I'm going to ask you to justify. So at least when you're doing your homework, make sure that you could justify if you needed to, okay? All right, the first one says, if a number is divisible by 6, then it is divisible by 2 and 3. What do you think? That's true. And before I justify it, let's move on to number 2, or part B on that one. It says, if a number is divisible by 2 and 3, then it is divisible by 6. That's also true, actually, yeah. I bring this up in this particular problem because I want you to remember this divisibility rule for 6 and how it's stated. Do you see right here where it says, I know there's so much going on this slide, but it's where it says if and only if? If and only if is logic language for saying we can start at the beginning and read the if at the beginning all the way through to the end and this is the result. Or we can start with the end and that's the if and go backwards. So all of our divisibility rules actually have an if and only if you take a look back in them. So if and only if, there it is on this one. If and only if and only if, it's on all of them, okay? So basically what this divisibility rule for 6 is saying is, if a whole number is divisible by a 6, then it is divisible by 2 and 3. But it's also saying, if a whole number is divisible by both 2 and 3, then a whole number is divisible by 6. We talked a little bit about language. We didn't encounter a lot of if and only if stuff in your book. That's kind of unfortunate because we use it with definitions a lot. But this statement, as it's stated, is actually true in both directions. And the reason's the same reason. What would the reason be? Why is it true? I think maybe you are complicating what I really mean when I say why is it true. No, that's basically what you got. You're both saying the same thing. And you're right. You're right. But the reason that we're here is that this is actually the theorem for divisibility by 6. Okay? I mean, that's the reasoning for why this is working. This is our divisibility rule by 6. Okay, now notice what C and D are doing. C and D make it sound like A and B did, right? I've got the if and only if. I've switched it around, but let's actually think very carefully about what it is saying. It says if a number is divisible by 8, then it is divisible by 2 and 4. And then you've got one that says if a number is divisible by 2 and 4, then it is divisible by 8. Now, first of all, it might be worth noting that this isn't written like the divisibility rule for 8, right? So without looking, can you guys remember what the divisibility rule by 8 says? What do I do to decide if a number is divisible by 8?
The last 3 numbers.
Yeah, I look at the last 3 numbers. and I ask if the last three numbers as a whole value, as a three-digit number, are divisible by 8, then the whole value itself was, okay? So this is not the divisibility rule by 8, right? So even if this ends up being true, I can't say that it's the theorem for divisibility by 8, right? Okay, so now we actually have to think, well, if it's not the divisibility rule for 8, maybe it's not true. Because if this worked, why wouldn't we use this, right? And that's kind of the idea. So let's actually see whether or not it's true by thinking through some values. It says if a number is divisible by 8, then it is divisible by 2 and 4. So what might help us to do is to list some values that are all divisible by 8, like your 8's times tables, right? So list me some values. What comes after 8 in the 8 multiplication tables? 16, 24, 32, 40. We'll do one more and we'll pause. What's the last one? Or the next one? 48, yeah. Okay, and they keep going. All right, so let's actually figure out, are all those numbers divisible by 2? Yes. Now think about that. Don't they have to be? Think about your multiplication tables for 8s. Are they all even numbers? Well, of course they are. So all those numbers are always going to be divisible by 2, so we kind of got a check mark on that one. What about divisible by 4? Yeah. And really the reason for why it is divisible both by 2 and 4 is because really 2 times 4 is 8. I mean, like that's the reason why it's going to work, is that 2 and 4 are factors of 8. So whatever the number is that has a factor of 8 in it is going to have a factor of 2 in it and a factor of 4 in it, right? That's going to work. So this is a true statement. And the reason, again, it doesn't actually tell us to say this, but the reason is because 2 and 4 are factors of 8. It doesn't look like of. Pretend like that says of. Factors of 8. Okay? Let's go the other direction, because the direction on part D is different. It says if a number is divisible by 2 and 4, then it's divisible by 8. So, can you guys find numbers for me that are divisible by 2 and 4? Give me some examples. We don't necessarily need to go in order of anything, but just give me some examples of things that are divisible by 2 and 4. 4. What else? 12. 16. 20. Maybe one more. 24. All right, those look good. And with the exception of the fact that you guys didn't actually tell me 8, all of that looks like the 4's times tables, doesn't it? Right? Because if a number is divisible by 4, isn't it automatically divisible by 2? Yeah, so whatever I do write down for this divisibility business between 2 and 4 is going to have to be multiples of 4. I just get the divisibility by 2 for free with it. I mean, I didn't list the number 8. That's okay, though. But these are all numbers that are divisible by 2 and 4. Are they divisible by 8? Not all of them, right? Not all of them. So in general, this is false. Sometimes I ask for counterexamples, right? An example where it shows something's false. Can you tell me which one of these? Give me one of them that would be a counterexample to this statement. 12. Here's an example. So let me actually show you how you could write it with some of the notation that we encountered last time. We didn't have a lot of practice with it yet, but 2 divides 12. Remember that line that's in between there is red divides. 4 divides 12. I didn't write that right. I didn't mean that line there. 4 divides 12. There we go. But 8 does not divide 12. You're welcome to write that out in English, not symbols as well. But that's what that's saying. 2 works and 4 works to divide 12, but 8 doesn't. Why in the world is part B acceptable for 6 and part D is not acceptable for 8? What do you think, Amanda?
Because 2 and 3 don't divide into each other, but 2 and 4 do.
Right. And remember, it isn't really the divide into each other, but it's the fact that they have a common factor.
Yeah.
2 and 3 don't have any common factors. Remember, we talked about this last time. Remember, I told you I bragged to my husband about you guys, about how amazing you were in looking at those patterns? 2 and 3 don't have anything in common. But 2 and 4, They share a factor. They both are divisible by the same number 2. Well, then we can't just multiply them together and say, that's good, I can have a rule for the number 8. And as a result, that's the reason we don't have a rule for the number 8, is because 8 can't be broken down into anything but a bunch of 2's, right? It's 2 times 2 times 2, and those all have things in common. So I don't have a divisibility rule like I have for 6 because the factors themselves aren't able to be split up in such a way that they don't have things in common. So that's going on there. All right, here's another one. This one's got some numbers in it that are not divisibility rules we've seen. Looks like I copied and pasted something funny. This shouldn't be here. I don't think it's on your paper. All right, ignore that piece. All right, it says answer each of the following without actually performing the division. Okay, so we all know you have a calculator and your calculator divides just fine. But the question is, just looking at the numbers, you shouldn't need your calculator. You should be able to look at this. This is really like a mental math kind of question. What about looking at this lets you know if this works or doesn't work? All right, so we're going to take a look at the first one. It says, is 34,051 divisible by 17? This one is very similar to something we have seen when we did mental math back in chapter 3 before. And some of you used it as an example on your test where you did something where you did breaking up and bridging, right? Where you broke something apart. Now, you guys did it with a multiplication problem from your test, but we did have that property with a division problem as well, where we looked at something like this, 34,000, and we said, okay, well, let's just look at the 34, and let's look at the 51 kind of separately and see if the number 17 divides into each piece of it. Okay, if it divides into each piece of it, it's going to divide the whole thing. So does 17 divide into 34? It does. Now, that's probably not you probably didn't learn your 17 multiplications tables. But if you double it, it will be 34, right? Okay. Does it divide into the 51? Yes, it does. What would it divide into? It would divide into it 3 times, exactly. So since it divides into each piece of this, it will, in fact, divide into the whole thing. Does that make sense? You guys with me on that?
Does it have to be broken up like that? Or are there different, I don't know. Like, could you do 300 and, I guess that would still work. Okay.
Could you do 340? You could. Yeah, the zero is sort of I mean, it just doesn't matter in this particular problem.
If there was a problem where there wasn't a 0, is that going to change?
It shouldn't make any difference either. You still should, if it's going to work, you should be able to break it into pieces that actually would work. Yeah. Yeah, so this one works. How about 19,031 divisible by 19? You can think of it in a very similar way. What do you think? Right. It goes into the 19, so we're sort of halfway there. But once we get to the 31, if I tried to double 19, it's already too big, isn't it? Yeah, we're at 38. So this one's a no. And of course, the issue is that the 19 does not divide the 31. I mean, that's where we get into a problem. Up here, we have the ability to say that 17 does divide 34, and 17 does divide, okay, let's try that again. 17 does divide 51. But this one didn't work. Okay, letter C. Please do not multiply that out. That would be highly inefficient. You have the number that is 2 times 3 times 5 times 7. And the question is it divisible by 5? The answer is automatically yes. Why? Do you know what these are called when they're written like this? I mean, you do know, you just might not remember. Does anybody remember what they're called? You're trying to say it, Kaylee. What are you saying? Factors, yeah. These are factors. This is actually a prime factorization because these are 2, 3, 5, and 7. I know we haven't talked about primes, but we will next class period. These are all prime numbers, 2, 3, 5, and 7. So this is a factorization. All of these are factors. And remember that very, very first definition in this section said if it's a factor, it divides it. It's a divisor. Those are all synonymous language. Factor, divisor, they're the same thing. So, yes, this works. 5 is a factor because, 5 divides it because it's a factor, right? All right, what weirdness is going on part D? Something weird, right? It's got this +1 business at the end. No. So let me ask you a question a little bit differently now, and we'll justify our answer of no in maybe a way you weren't expecting. If you had part C, and 5 is a factor, which it is, right? How will the number end? In a 0 or a 5. Everybody good with that? Okay. What happens when I add 1 to it? It's going to end in a 1 or a 6. So it's not divisible by 5, is it? There's nothing special about the 1 in the end except that it's not a factor of 5. What if the 1 in the end said 5? It would work, wouldn't it? It would still then be adding it 5 to it would end up making it still divisible by 5 because it would make the 0 or the 5 at the end switch to, well, the other option, actually. So this is a no. And I'll justify it the way I just said because the final digit, or you could say the ones digit, that might be even better. But the final digit is a 1 or 6. And that doesn't work, right? Does not work. Okay, we're going to go just a little bit deeper down the bunny hole that we started earlier about divisibility. We started over here and we talked about the fact that if we're divisible by 8, it's automatically divisible by 2 and 4. That's what part C did, right? And so we're going to do the same thing over here now, but we're going to start with a number that's a little bit larger. This number is 24. So if you have 24 and it divides some other number, like let's say you have the number 96. I don't know why I thought of that one, but I did. 96 is divisible by 24. Okay? So if you know a number is divisible by 24, what else will it automatically be divisible by?
3.
3. Okay, so why 3?
Well, 3 is a factor.
Okay, good. So somebody help Sydney out. What's the other factor that would go with 3? 8. So 3 and 8 are kind of, they're sort of pairs, right? They're pairs of numbers that go together. Can somebody else give me another pair? 6 and 4. And I heard 2 and 12. Is that all of them? And technically 1 and 24. Yeah. So these are all of the factor pairs that make up the number 24. Now, we don't have to list them in pairs like this, but it is somewhat helpful to think of it that way because we make sure we get all of them. You might actually start with the smallest one and then work your way up, until you run out of options. So if you did that, you might start and say, okay, well, I've got 1 and 24, and I'm going to kind of work my way inward, and then I've got 2 and 12, and then I've got 3 and 8, and I've run out of space. And then I have 4 and 6, and I've run out. I mean, there's no more space between 4 and 6 for numbers, right? So you might also think of it in ordered pairs, sort of working your way inward like on a number line would be. No matter what you get, though, you're going to get these numbers right here. Notice I excluded the 24 just because of the way the question's asked. It says, if 24 divides the number m, what other numbers must divide m? 1, 2, 3, 4, 6, 8, and 12. All the factors of 24 also have to divide that value because they're factors of 24. So they're going to be factors of the first number as well. Okay? So that always happens. All right, another number, this question is similar to the one we started with last time, or ended with last time, I guess, actually. It wants us to fill in the blank. Fill in the blank with numbers, so that the number that's got filled in the blank for is divisible by the following. So we're going to start with 2. What numbers could go in the blank so that this 6-digit number is divisible by 2? 2, 4, 6, 8. I'm missing one more. 0. Yeah. That's our divisibility test of 2's, right? The divisibility test by 2 says that the last digit has to be basically an even number, is 0, 2, 4, 6, or 8. It's all about the last digit. Okay, how am I going to get a number that needs to be divisible? How do I get the value that needs to go in there so that the number is divisible by 3?
You add it together and
Uh-huh. Okay, so should we add the digits together, do you think? Yeah, let's see what we have so far to work with. All right, sounds good. So let's add up 5. 5 plus 4 plus 3 plus 2 plus 2. What do we have so far? 16. Is 16 divisible by 3? No. But what number after 16 would be? 18. What's the next number that would be? 21, and then 24, and then give me one more just for good measure. 27. Okay, so we'll stop right there. What would I have to add to 16 to get to 18? 2. What would I have to add to 16 to get to 21? 5. What would I have to add to 16 to get to 24? Basically, I'm filling in this blank. What do I need to add here? 8 is correct, yeah. And what would I have to add to 16 to get to 27? 11, and that's too big, right? I'm supposed to have a single-digit number. So the different options that I have for my answer here are 2, 5, and 8. Now pause with me for a moment. We got the 2 by saying, how do we get from 16 to 18? It's 2. But what do you notice between 2, 5, and 8? You just add 3 the next time because this would be called a what? Oh. Is arithmetic, yeah. It's arithmetic. The addition one's arithmetic, the geometric one's multiplication, yeah. So this one we called an arithmetic sequence, right? You add 3 to get the next term. And you could keep doing this, right? It's just that when we get to 11, it's too big because I don't have a single digit that has a value of 11. It's a 2-digit number. So once I had 2, I just needed to add 3 to it a couple more times before I ran out of options. All right, part C then says, whoops, that's not what I did. Part C then says that I want a number that will be divisible in the blank, a number to put in the blank so that the value will be divisible by 6. So what's the divisibility by 6 rule again? 2 and 3 both go into it. So what number works for both 2 and 3? 2 does, and 8 does. I have 2 options. If the number 2 is in the blank, it's divisible by 2. It's divisible by 3, so it's divisible by 8. I'm sorry, 6. 6. If I put the number 8 in the blank, it's divisible by 2, and it's divisible by 3, so it's also divisible by 6. Okay. Here's another kind of fun one that's talking about language. This is almost like logic stuff like when we were doing it before when you start looking at these divisibility rules. There's a lot of that going on in here. All right. If a number is divisible by 5, can it be divisible by 10? Yes, it can. Can you give me an example? So let's just like say that this is like 1 here. Yes, what number?
Oh, I said 40.
40. Is 40 divisible by 5? Yes. Is 40 divisible by 10? Yes. So can it be? Yes. The second question here says, must it be? No. No. Can you give me an example?
35. Right.
So 35 would be an example that doesn't work. It's divisible by 5, but it's not divisible by 10. Okay. Be real careful with the can versus must. This is like you telling your parents, I can't go somewhere tonight. And the answer is like, you can't or you won't, right? There's a difference. The language we use, English, it's very specific, so be really careful with it. All right, the next one, same kind of question, but where numbers are done in a different order. If a number is divisible by 10, can it be divisible by 5?
Yes.
Yes, and it almost feels weird to say can in that, because why? Because it must. And why? Why must it?
Because any number divisible by 10 must end in a 0, and the divisibility rule for 5 is that it's 5 or 0. So since it's always 0, then it will be always divisible by 5.
That sounded great, Amanda. All multiples of 10 end in 0. Hence, they are divisible by 5. Did everybody follow that? So that's different than part A, right? Because what's it take for a number to be divisible by 5?
0 or 5.
Yeah, the ending digit can be a 0 or a 5, which means that some of them, the ones that end in 0, are divisible by 10, and some of them, the ones that end in 5, aren't. All right, I think this is our last one. Yeah, it is. This is a cute one. A number in which each digit except 0 appears exactly 3 times is divisible by 3. For example, 777,555,222, 414,143,313 are both divisible by 3. So do you understand their description so far? If there's a number in there, it's in there 3 times. There's 3 4s, there's 3 7s, there's 3 2s, there's 3 1s. Whatever it is, it's there 3 times. So the first question says, explain why this statement must be true. Why would this work? Okay, let me have someone over here since Amanda answered our last one. Over here. Who did you want to say something, Madison? Do you have an idea? Okay, go ahead.
If you add the numbers together, like 7 plus 7 plus 7 or 2 plus 2 plus 2,
Okay.
it's divisible by 3. So you don't have to look at like the number as a whole, but even just sections of the number. You can add them together by 3s and they are divisible by 2.
Okay, I'm going to give you your example with a 7. So let's say, so each value like 7 is there 3 times. So it's there 3 times. So we have, for instance, if we had the 7s, like 7 plus 7 plus 7. And what's a shortcut way of writing 7 plus 7 plus 7? 7 times 3, which has a factor of 3. Right, so this works because of this property. I have 3 of them there, so when I add those 3 of them, whatever them are, I get the value times 3, and then it's automatically divisible by 3. Okay, does everybody make sense of that? It's kind of cute, right? If you saw that happen, that would be a very clever way to avoid having to add all the digits together and prove it that way. But part B says, must this be true? Must a value have 3 of every digit in order to be divisible by 3? No. Can you give me an example?
6.
Can you give me a 3-digit example, just for fun?
300.
Okay, 300. That'd be a very straightforward 3-digit example, right? 300. Is 300 divisible by 3? Yes. Does every digit but does the 0 appear 3 times? No, 3 does not appear 3 times, right? And of course, I mean, Amanda's right when she said 6, and numbers like 24 and 72 and things like that. All of those would be divisible by 3, but they're not, fitting into this description. All right, sound good? Excellent.